Okay, so welcome back. And so here's what I'm going to talk about now. So I want to bring everything together for one last example of how, hey, how would you, a good typical question on an exam, and what kind of questions you could answer for one particular problem. Okay, so I'm going to use the third final exam data that we talked about before. So remember this data, so I'm going to use this data, okay, at the bottom there, when we related third exam scores and final exam scores. Okay, so I'm going to use that data and I'm going to say, okay, here are some questions I could ask you in a step-by-step process. Okay, so using that data, again, just where we want to predict someone's grade on the final exam given their grade on the third exam. Okay, so first we have the data, right? And so the first step is to do a scatter plot. Okay, now you can do a scatter plot on your calculator. Now again, I'm not going to probably ask you to do this on the exam, but what you want to do is, you're going to have to do this anyway, but you want to put your data into lists. So why don't we do that? Because we're going to have to do that anyway. So let's go put our data into our list. So go to Stat Edit, and let's put the data in the calculator. So 65, 67, 71, 71, 66, 75, 67, 70, 71, 69, 69. So that's the third exam data. And now I'm going to go to L2. I'm going to put in the final exam data. So 175, 133, 185, 163, 126, 198, 153, 163, 159, 151, and 159. And so just double check your data, make sure you have the right numbers of data in there. And so I've got my list 1 and list 2, so now I'm going to quit out of this. Now, here's what I'm going to do. I'm going to do a scatter plot. So remember back in chapter 2 and 1, so if I go to my, my stat plot up here, okay, or excuse me, I'm sorry, stat plot right here. So if I go to my stat plot, oops, sorry, I did y equals, hold on. So second y equals, so I do second y equals, and there's my stat plot. So now I want to go to my first one and make sure that it's on. So if you hit enter, okay, now here's my stat plot. Now if your stat plot is not on here, make sure you hit select on. Mine is already selected. So I'm going to go down. Okay, now here's where you can select your plots. Now we've done this before with histograms, and you could do this with box plots by just scrolling over. But I want the first one, scatter plots, which is just with the dots. So if you do that, okay, so if you do that, now look what it asks you for. It changes. So now it asks you, where's your X list at? And mine's in L1, and my Y list is in L2. And so it asks you for what kind of mark you want. Well, I'm just going to keep it that one. You can use all these different ones, or that one. I'm just going to leave it alone. So now at this point, all you have to do is go to your zoom right here. So go to zoom, and what you want to do is you want to go down to stat plot, or not stat plot, but zoom stat. There it is, zoom stat. So you want to go to number 9, and if you hit enter on number 9, there it is. It actually takes your data and plots it, so you don't have to worry about playing with the window if you use the stat fit or fit stat. Okay, or zoom stat, I mean. So zoom stat, so there's my scatter plot. Okay, so it looks like there's a linear relationship. I mean, I've got this dot over here, but it seems like there's a linear relationship. So now I can go ahead and calculate the correlation coefficient. Okay, so again, that would be step one, right? Now that I see that there's a relationship, let's, from this data, I need to know what the correlation coefficient is, right? So again, I could ask you that on the test. So for this data, how do I get the correlation coefficient? Well, let's quit out of this. I'm going to go to, you know what, I'm going to go, you could do linreg, right, on your calculator. So you can go to StatCalc, and you could use linreg, right? You could do that one. You could use one of the linreg functions. Or you can go to tests and use the linreg t-test, which is what I'm going to use. Why? Because then I'm going to answer all my questions here in a minute. So now, so L1 is my X list, L2 is my Y list. I'm going to choose not equals 0. Why? For my test, right? For the significance of my correlation, right? So I might as well just put not equals and test it now. So, and then I'm going to put Y1. Now, how do you put Y1 in here? Well, watch this. How do I store my regression equation into my calculator? Well, by putting Y1 there. How do you put Y1 in there? Well, if you put your cursor right where it's flashing, then what you want to do is you're going to go to your vars. So you go to vars, hit vars, and now I get this function, this menu here. Now what I want to do is I want to go over to yvars and look at number 1. Number 1 says function, so I'm going to hit enter on function. And now there's all of my functions I can choose, and if you just hit enter on Y1, it'll put Y1 right into where you want it, and then that's it. So then go down, so go down to calculate and then hit enter, and there's all the information I need. Okay, so if I scroll down, look what I get for my correlation, right? R is what? 0.663. Okay, so my R value is 0.663. There's my correlation, right? So R is 0.663. Now, is it significant? Okay, so just because I have my correlation, it looks like there's a moderate correlation maybe. But is it significant? Well, that's where my T statistic comes in, right? It says T is 2.658, right? But what's the p-value? P-value is 0.0261, or 2. 0.2622. Okay, or if you want to go 4, it's 0.262. Okay, so what does that say? Well, if I'm testing at a 0.05 alpha level, then my p-value is less than alpha, and therefore I reject the null. Remember what the null and alternative hypotheses are for a correlation coefficient. It's rho is equal to 0 versus rho is not equal to 0. So in this case, if my alpha is 0.05, then I have a significant correlation. So that's great. So it's significant. So if alpha is equal to 0.05, then I have R is significant. Great. Now, if R is significant, now I can do my regression. Well, I've already got it on my calculator from doing linreg t-test. Well, again, just like before, I get my regression equation. Okay? Y equals negative 173.513 plus 4.827 times x. And so now I've got my regression equation, but also notice something here. If I go to y equals, right, or excuse me, I'm sorry, y equals, if I go to y equals right there and hit it y equals, look at that. I've already got my regression equation in there. Watch this. If I go to graph right here, watch what happens when I graph. It plots my least squares regression line right through my scatter plot. Is that not cool? So now I've got not only the graph, but I also got the equation. Okay, so I can actually use the calculator to say, okay, what's the predicted value of x equal to 70? Okay, well then I can just use calc right here. I can do calc, second calc, and now I can do value, so I can just hit enter on value, and then now I can stick in an x value. Well, let's put in 66. So there's 66, and now if I hit enter, watch what happens. There's my predicted value right there. There's my predicted value of y based on x value. Okay, so I don't have to use the function, right, the equation. I could use my calculator if I plot it here. So that's the cool thing about the calculator. But if you don't want to use the calculator, you can do the same thing. Just take 66, right, and plug it into here. So negative 173.513 plus 4.827 times 66, right? And then just plug and chug. So if I quit out of this and I just do negative 173.513 plus 4.827 times 66 and hit enter, I get 145.069. So I get the same answer. Okay? So now here's the thing. Now that I have my regression equation, I can ask you, hey, give me the predicted value for if somebody gets an exam score of 66. I could also ask you to give the interpretation of the y-intercept based on the context of the problem. I could also ask you to give me the interpretation of the slope. Now, we've already talked about these two, so you should see that in your notes. Okay? So you should be able to give me those things once you are able to get the regression equation. Also, I might ask you to tell me what proportion of the variation that we see in the final exam scores is explained by the model. Or in other words, what proportion of the variation that we see in the final exam scores is explained by the variation that we see in the third exam scores. What is that? That is r squared. That's the coefficient of determination, right? So the coefficient of determination, remember, is r squared. So what's r squared? Well, let's square it. 0.663. And what does that give it? That gives me 0.4395. Well, again, this is usually written as a percentage. So we're going to write it as 43.95, or approximately 44%. Right? So what does this mean? Well, in words, because that's, again, getting the value is one thing, but interpret it. Right? What does this mean? It means that 44% of the variation that we see in the final exam scores is explained by the variation that we see in the third exam scores. In other words, 44% of the variation that we see in Y, right, is explained by the model. So in other words, this is not a very good model, right, because it only explains 44% of the variation that we see in the Y data, in the final exam scores. Okay? So this is not a very good model at predicting what somebody is going to get on the final exam. Make sense? Okay. So that is regression. And so just keep in mind that it's a step-by-step process that builds on one another. So I hope this made sense. And again, do some of the examples in the textbook, do the examples on the PowerPoint presentations. And if you have any questions, reach out to me. Great, thanks.